So we were discuss about Otto cycle, and Otto cycle is the air standard cycle of petrol engine. So we are deriving the efficiency of Otto cycle. So from the thermal efficiency, what we get 1 minus T1 into T4 by T1 minus 1 divided by T2 into T3 by T2 minus 1. So this equation, that temperature equation we get from the thermal efficiency. Thermal efficiency we got in terms of your temperature. Then you have to convert into in terms of your compression ratio. Okay. So what you have to do? We have to replace this T1 by T4, T1, T2, T3 by T2, that you have to replace in terms of your compression ratio. So what do you mean by compression ratio? That we know. Compression ratio is equal to total volume by clearance volume. So if you see the Otto cycle diagram, the PV diagram of Otto cycle, then tell me which one is your total volume? Total volume is your here to here. This volume is known as your which volume? Total volume V1. So no, this total volume. This is your total volume. So here to here volume is known as your which volume? When piston is at top dead center and cylinder, that volume is known as your clearance volume. This clearance volume is equal to also volume at 2 point V2. This volume is equal to also volume at 3 point state 3, at V3. So in Otto cycle, V3 is equal to V2 is equal to what? That is equal to Vc clearance volume. So when piston travel from TDC to BDC, top dead to bottom dead center, the volume covered by the piston is known as your what? Swept volume or stroke volume. So Vc plus Ps, that is your total volume was V1. V1 by total volume is your V1 divided by total volume by clearance volume. So clearance volume I can write also Vc, or you can write V2. Is or no? So if I can write Vc and V2, and then what is the compression ratio? Compression ratio R is equal to total volume by clearance volume. What is your total volume here? V1. What is your clearance volume? Vc. So I can replace the total volume, clearance volume by V2. So R is equal to V1 by V2, compression ratio. Okay. So you have to derive the thermal efficiency in terms of your compression ratio. Clear? So now considering the what is your 1 to 2 process? 1 to 2 process is your isentropic compression. So if we consider 1 to 2 process, that is isentropic process, what is the temperature and volume relation? T2 by T1 is equal to V1 by V2 to the power gamma minus 1. Okay. So what is your V1 by V2? V1 by V2 is your R. T2 by T1 is equal to V1 by V2 to the power gamma minus 1. What is your V1 by V2? V1 by V2 is your R. R to the power gamma. So I am taking this one as your equation number 2. So R is called compression ratio. For isentropic process 3 to 4, what is your 3 to 4? Isentropic expansion. So if you consider 3 to 4, V3 by T3 by T4 is equal to V4 by V3 to the power gamma minus 1. 2 by 1, T2 by T1, final temperature by initial temperature. Then high temperature T3 divided by T4 is equal to V4 by V3 to the power gamma minus 1. So, though 4 to 1, you can see here, though 4 to 1 process is your which process? Four to 1 process is your constant volume process. Though 4 to 1 is your constant volume process, this 4 to 1. So, I can write V1 is equal to V4. V1 is equal to what? V1 is equal to your V4, because 4 to 1 is your constant volume process. So 2 to 3 is also constant volume process. So what I can write? V2 is equal to V3. So though V2 is equal to V3 and V1 is equal to V4, because 4 to 1 is your constant volume process and 2 to 3 also constant volume process, then the equation we got is your T3 by T4 is equal to V4 by V3 to the power gamma minus 1. So in place of your V4, what I can write? V1. V4 is equal to V1, 4 to 1, constant volume process. V3 is equal to V2, because 3 to 2 is your constant volume process. So in place of your V4, I can write V1. In place of V3, I can write V2. So what you get? V1 by V2 to the power gamma minus 1. And we know that V1 by V2 is your which ratio? Compression ratio. Compression ratio denoted as R. So T3 by T4 is also we get, that is R to the power gamma minus 1. Clear? That I can put this in as equation number 3. Then equating equation number 2 and 3. So if I equating equation number 2 and 3, so you can see the right hand side of the both equation is same. So the left hand side of the equation will be equal, then T2 by T1 is equal to T3 by T4, or we can say that T4 by T1 is equal to T3 by T2. Okay, I can arrange it also, this one. All these two values are equal. So if you divided T4 by T1 is equal to T3 by T2, then T2 by T1 is equal to T3 by T2, or you can say that T4 by T1 is equal to T3 by. We only arrange. Here T4 is there, T4 will become this side. So T4 by T1, T2 will become this side. So T4 by T1 and T3 by T2. So as T4 by T1 is equal to T3 by T2, if I apply in the equation number 1, so what is your equation number 1? Equation 1 is your thermal efficiency in terms of temperature 1 minus T1 into T3 by T2 minus 1 divided by T2 into T3 by T2 minus 1. So I can write T3 by T2 is equal to T4 by T1. So in place of a T3 by T2, I can write T4 by T1. So T4 by T1 minus 1. Or sorry. So what is your equation number? Thermal efficiency 1 minus T1 T3 by T2 minus 1 and T2 T3 by T4 by T1 minus 1. That was the equation. See here. Equation T1 is T1 into T4 by T1 minus 1 divided by T2 into T3 minus 1. So in place of your T4 by T1, what we can put? In place of your T4 by T1, we can put T3 by T2 because it is equal. So T1 into T3 by T2 minus 1, T2 into T3 by T2 minus 1. So T3 by T2 minus 1, T3 by T2 minus 1. It will be cancelled out. What is left? 1 minus T1 by T2. So in place of a T4 by T1, what we can put here? T3 by T1 minus 1. So both are cancelled out. What is left? 1 minus T1 by T2. So as we know that T2 by T1 is equal to R to the power gamma minus 1. Then what is your T1 by T2? T1 by T2 is your 1 by R to the power gamma minus 1. 1 minus T1 by T2. So 1 minus T1 by T2 we can write also 1 minus 1 by T2 by T1 I can write also. So what is your T2 by T1 is equal to R to the power gamma. So 1 minus 1 by R to the power gamma minus 1. That is the thermal efficiency of which engine? That is your petrol engine or Otto cycle. This is the thermal efficiency. So from the temperature, and we are considering two processes 1 to 2 and 3 to 4 process. We get the temperature and we equate the temperature. And then we derive that 1 minus 1 by R to the power gamma minus 1. It is R compression ratio. What is gamma? Ratio of specific heat. Cp by Cv is equal to gamma. Clear? So that is the derivation of your Otto cycle efficiency. Okay. For air the ratio of specific is assumed to be constant because air is an ideal gas. So the specific heat of the ideal gas will be always constant here. So ratio of specific heat is also constant. That is gamma is equal to assumed to be constant, that is 1.4. Thus efficiency of the Otto cycle is the function of compression ratio only. Then efficiency of the Otto cycle is only depend upon the compression ratio, that is 1 minus 1 by R to the power gamma minus 1. The efficiency of the Otto cycle increases with the increase in compression ratio, it will be reciprocal. Okay. Practically the compression ratio of the petrol engine is restricted to maximum 9 or 10 due to phenomenon of knocking at high compression ratio. That was discussed also. Why the compression ratio of the petrol engine is kept up to 9 to 10? Why not 22 to 16? Because if we are compressing something, that means we are preheating something. If we are preheat the petrol and air with a high compression ratio, then there may be a chance of pre-combustion. If there will be a chance due to pre-combustion, knocking will be created and knocking will decrease the efficiency of the cycle. So that's why we are keeping the petrol engine efficiency will be 9 to 10. Then we will discuss about diesel cycle. The diesel cycle is an ideal cycle for reciprocating compression engine. That means CI engine. So ideal cycle for CI engine or thermodynamic cycle for CI engine is your compression ignition engine is your what? Diesel cycle or diesel engine. Diesel engine only air is compressed during the compression stroke, thus eliminating the possible of auto ignition. So if only we are compressing the air, so there should not be the chances of auto ignition because no fuel is added here. Okay. Therefore, diesel engine are designed to operate at very high compression ratio, that is 12 to 14 or you can say 16 to 22 also. Okay. So diesel engine has a high compression ratio because you are compressing only air. But in the petrol engine we are compressing air and petrol mixture. So that means if you increase the compressor, then we have a chance of pre-combustion. But here there will be no chance of pre-combustion, because air, if you compress the air that much of temperature, air cannot only burn. Okay. Let's discuss about the pressure volume diagram and temperature entropy diagram of diesel cycle. So see, in the diesel engine, 1 to 2 is your isentropic compression. 1 to 2 is your isentropic compression. Then 2 to 3. In case of your petrol engine, you are constant volume heat addition. But in case of your diesel engine, constant pressure heat addition. The air will be compressed up to state 2. Then fuel will be start injecting at point state 2. And it will be end at state 3. Okay. So constant pressure heat will be added here. 2 to 3 is your constant pressure heat addition. Then after heat addition or after fuel injection, the air and fuel will be auto-ignited. The fuel will be auto-ignited and it will be produced as the hot gases. The hot gases push the piston to move downward from, that means expansion T3 to T4. 3 to 4 is your isentropic expansion. So after expansion, when the exhaust valve will be open, then what will happen? The exhaust gas will be coming out of the cylinder. That means some heat will be rejected to the atmosphere. So 4 to 1 is your heat rejection. So in the Otto cycle, 1 to 2, 3 to 4, 4 to 1 will be same. Only difference is here, in case of your Otto cycle, there are 2 to 3 is your constant volume heat addition. But here constant pressure heat addition. So 2 to 3 Q in, 4 to 1 Q out, 1 to 2 work input. Because it will be compressor, compression work always needs work input. So 3 to 4 what we get the work. Okay. So 1 to 2 isentropic compression. So if I draw the TS diagram, 1 to 2 isentropic means entropy must be equal, S1 is equal to S2. So compression means temperature increases from T1 to T2. Clear? Then 2 to 3 is your constant pressure heat addition. The slope of the constant pressure and volume will be, this is the way to represent the constant pressure or constant volume also here. But constant pressure and constant volume, the slope of the constant volume will be more than that of your constant pressure. Okay, if you consider both the diagram. So 2 to 3 constant pressure heat addition, 3 to 4 isentropic expansion. So isentropic means S3 is equal to S4, 4 to 1 that will be heat rejection, constant volume heat rejection. So you can see here 2 to 3 the slope is less than that of 4 to 1. The slope of the constant volume will be more than that of the slope of the constant pressure. Okay. So that is the TS diagram of the diesel cycle. So in the diesel cycle you can see here, see what is the volume here to here. If you consider this one is your top dead center and this one is your bottom dead center. Piston travel from TDC to BDC. So this volume is known as your which volume? This volume is known as your swept volume or stroke volume. When piston is at top dead center and cylinder head, this volume is known as your which volume? Clearance volume. So clearance volume plus swept volume, that will be give you a total volume, that is V1. Total volume is your V1. Okay. Then VC is equal to how much? VC is equal to, you can see here, VC is equal to V2. VC is equal to what? VC is equal to V2 here. Okay. So that is that much. Then we will go for solving the, derive the equation, thermal efficiency of the, in the thermodynamic process undergoing a cyclic process. Though why it is called cyclic process, it will start at one point and end at one point. So initial and final state will be same. So that is known as your cyclic process. So if you are applying the first law of thermodynamics for cyclic process, the net work done is equal to net heat transfer. So W net is equal to Q in minus Q out. So what is your Q in? Constant pressure heat addition, 3 to 2 constant pressure heat addition. So in the constant pressure heat addition, what is your heat supply? Q is equal to mCp minus T2. Though it will be mCp minus T2. So that means Q is equal to Q in. Q in is equal to how much? Constant pressure heat addition. Constant pressure heat addition means mCp T3 minus T2. So here per unit mass we are calculating. So Q in, because mass flow rate should be equal throughout the process, Q in by M, that is small q in. Unit will be kilojoule per kg is equal to If mass will be divided, what is left? Cp into T3 minus T2. Cp into T3 minus T2, that constant pressure heat addition.